Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to Dr. Ahmad Fuad. Today we will discuss about the current application of the alternative fuel in the internal combustion engine. For our team, we select hydrogen as the alternative fuel. This is my team member. We have Elson, we have Jimmy, we have Loh, I'm Amirul, and Tasa. For the introduction and history, hydrogen H2 is an alternative fuel that can be produced from the domestic resource. Under the Energy Policy Act of 1992, the interest in the hydrogen as the alternative transportation fuel stem from the its ability to power fuel cell in the zero emission vehicle, its potential for domestic production, and the fuel cell fast filling time and the higher efficiency. In fact, the fuel cell coupled with the electrical motor in the 2 to 3 times more efficient than the internal combustion engine running on gasoline. Hydrogen can also serve a fuel for the internal combustion engine. However, unlike the FCEV, this produce tailpipe emission and are less efficiency. Next, I will pass this presentation to Jimmy.
Okay, thank you, Amirul. My name is Jimmy. I'm going to explain about how we can obtain the hydrogen fuel. The source of hydrogen fuel can be derived from a few methods. One of those is produced from fossil fuels by steam methane preforming of natural gas and other light hydrocarbon, partial oxidation of heavier hydrocarbons, and many more. Steam methane preforming, or known as SMR, is a method of producing hydrogen from natural gas, which is mostly methane. This source is the cheapest source to use for hydrogen production. However, the process consists of heating the gas to between 700 to 1100 degrees Celsius in the presence of steam and a nickel catalyst. The resulting endothermic reaction breaks the methane molecules and form carbon monoxide and hydrogen. Next is the hydrogen fuel also can obtain through methane pyrolysis. Pyrolysis of methane is a hydrogen production process from natural gas. Hydrogen separation occurs in one step via flow through a molten metal catalyst in a bubble column. It is a no greenhouse gas approach for potentially low-cost hydrogen production be measured for its capability to scale up and for operation at scale. The process is conducted at higher temperature, which is around 1065 degrees Celsius or equivalent to 1950 degree Fahrenheit. Another method is coal gasification. This process is use steam and oxygen to break down a molecular bond in coal and form a gaseous mixture of hydrogen and carbon monoxide. Okay, then the carbon dioxide and pollutant may be more easily to remove from gas obtained from coal gasification versus coal combustion. The next one is hydrogen fuel also can be produced through the electrolysis of water. This method consists of using electricity to split water into hydrogen and oxygen. Electrolysis of water is 70 to 80% efficient, while steam reforming of natural gas, which we mentioned at the early stage just now, has a thermal efficiency between 70 to 85%. Last but not least, the hydrogen fuel can also be produced through a process called biomass gasification, steam reforming, biological conversion like biocatalyst electrolysis, or fermentative hydrogen production. Fermentative hydrogen production can be done using direct biophotolysis by green algae, indirect biophotolysis by cyanobacteria, or photofermentation by anaerobic photosynthetic bacteria, and dark fermentation by anaerobic fermentative bacteria. That's all from me. Thank you. I'm going to pass to my friend Tasa.
Thank you, Jimmy. And I'm THASARATHAN. We are going to discuss about the distillation process of hydrogen gas. Most of the hydrogen produced today is made via steam methane reforming, a mature production process in which high temperature steam 700 degrees Celsius to 1000 degrees Celsius is used to produce hydrogen from the methane source, such as a natural gas. So the natural gas are sent to the desulfurization column, so to sulfurize the gas, and it's sent to the reformer. In steam methane reforming, methane react with steam under 3 to 25 bar pressure in the presence of catalysts to produce hydrogen. Steam reforming in endothermic, that is, heat must be supplied to the process for the reaction to proceed. The gas are then sent to the high shift converter and then sent to the low shift converter. After the process, it's sent to the amine unit. That was the final process step called pressure swing adsorption. Carbon dioxide and other impurities are removed from the gas stream, leaving essentially pure hydrogen. That is from the methanator, it's produced H2, that is hydrogen, as a product. That's all from me, and I give to the floor to proceed.
Mike.
Okay, sorry, I didn't open the mic. Okay, all right. So I repeat again. So thank you, Tasa. And hi, my name is Lo Ji Pei, and I will present the advantage of using hydrogen fuel burst. The first one is it does not produce harmful emissions. When hydrogen is burned, it does not emit harmful substances. Basically, it reacts to oxygen without burning, and the energy it releases can be used to generate electricity used to drive an electric motor. And the second one is fuel efficiency. Compared to diesel or gas, hydrogen is much more fuel efficiency as it can produce more energy per pound of fuel. This means that if a car is fueled by hydrogen, it can go farther than a vehicle loaded with the same amount of fuel but using a more traditional sources of energy. And the third one is renewable. Hydrogen can be produced again and again, unlike other non-renewable sources of energy. This means that with hydrogen, you get a few sources that is unlimited. Basically, hydrogen energy can be produced on demand. Also, it is widely available. All that is needed to break the water molecules so it gets separated from oxygens. And next, I will go to this advantage of using hydrogen fuel. The first one is it's very expensive. Hydrogen is expensive because it takes a lot of time to separate the element from others. If the process were really simple, then a lot would have been doing it with relative ease, but it's not. And the second one is difficult to store. Hydrogen is very hard to move around. When speaking about oil, the element can be sent through pipelines. When discussing coal, they can be easily carried off on the back of the trucks. When talking about hydrogen, just moving even small amount is a very expensive matter. For that reason alone, the transport and storage of such a substances is not impractical. The last one is highly flammable. Since it is a very powerful source of fuel, hydrogen can be very flammable. In fact, it is on the news frequently for its many risks. Hydrogen gas also burns in air at very wide concentrations, between 4 and 75%. That's all from me, and I will pass to my team's member, ELSTON.
Okay, hello, my name is ELSTON, and I'm going to present about my opinion of the alternative fuel for the near future. In my opinion, I think the alternative fuel for vehicles in the future is still questionable. Why? It is because of the production of electric vehicles are getting more and more popular nowadays. In my opinion, I still strongly support the internal combustion engines for vehicles in the future. So therefore, I support the hydrogen as the alternative fuel in the near future, and the vehicle manufacturers should provide a fund for a research in developing hydrogen as the alternative future fuel. So I think that is all from us. Thank you.
Thank you.